use that. Actually, you can integrate everything together. You use traditional digital driver. Use digital certificate. But in the hidden credentials, usually each credential only have one attribute, so that you cannot combine things together.
But if you come from the same credential authority, that credential authority could say.
Yeah, if you have a digital driver license,
you could still separate it, but there could be. It's not easy. There's a lot involved. But.
And another difficulty with it is that you might have a lot of different attributes, and of course, the complexity of this is ordered the number of attributes that you have in the policy and the number of credentials you're using. So if I have a large number of credentials with this one person, I have to use them all now, and that might make the system not usable. Whereas in another situation, I can say, well, for what I'm applying for, these are the things that are going to help me, and so I can make it a more efficient protocol. It'd be another problem with doing the integrity things. It would make it possibly unusable in some cases.
Since we have some time, can you maybe outline some future work that you
outline some future work in this area? Okay. In this particular area, well, one of the things that we're looking at, like I mentioned, is things for services and other things like this. But in the trust negotiation area, there's another thing that's a consideration that we don't consider, and that is that I will only use my credential if you have authority to see the credential. And for things like the message inference problem, where if I have message M1 and then ask for M2, that I could probably infer that you got access to M1. Well, if Bob is semi-malicious, he could have the policy for M1B. You have to have top secret clearance for something. And perhaps I can't show you I have top secret clearance unless you have top secret clearance. But now you have this inference thing where Bob might be able to learn that, so I can't use my top secret clearance credential unless I know Bob has a top secret clearance credential. And it's not clear how do we have this so that you could have both people enter a set of credentials, and each credential kind of has their own policy now. And I will only use this credential if I have a policy, if you've satisfied my policy for that credential. How do we kind of merge all these things together in a way that I'm only using the credentials you have authorization to see, you're only using credentials that I have authorization to see, but based on those credentials, do I get access to the document? I'm also doing some other work in other types of secure protocols. I've done some things with contract negotiation, which is a different type of negotiation entirely than this. This is kind of a trust-based negotiation. In that, Alice has a set of requirements for a contract, and Bob has a set of requirements for the same contract. And these constraints it might be the case that these constraints don't satisfy each other, and that there's no way there's a valid contract that satisfies both persons' constraints. But you'd like to know those securely without telling you, well, here are all my constraints about my business practices, and here are all my constraints. Now let's match them up. So finding a secure way to match constraints is the first part, but then suppose that things match. Well, that doesn't do us any good because now we have to figure out a valid contract that we both agree to. So the second part is how do you generate a contract that's fair and fairness is something to the degree of I can't control the outcome. Of all the possible valid contracts, they're randomly chosen between them. Of course, there might be situations where you have a win-win situation where Alice and Bob both prefer one contract over another contract, and we also have a filtering type process that would allow that only efficient, fair contracts are chosen. Some other work, I've done some things with biometric comparisons. Basically, how do you implement a PIN system with a biometric smart card? A normal PIN system is fairly easy to have a secure check because equality checks are much easier than approximate checks. So how do you develop protocols that will tell the bank essentially, yes, this person is the person that they're saying they are, without revealing the fingerprint to the bank? Other work, I've done some work with privacy-preserving electronic surveillance, where you have some government entity that wants to monitor a subset of the population because they have perhaps they have some type of warrant, or they have some credible suspicion that this person is doing something. Now, this person has a right to privacy. It's not right to go out and publish, we're looking at all these people, because this person has some right to privacy. because they have not been convicted for anything. But the second thing is that if I go out and tell everybody, well, these are the people I'm looking at, it makes the surveillance system less effective, because if I have a friend that gets this list, of course, I'm going to disappear and not use all the identities that they're looking for. But another problem is that you can't just send to this government agency every transaction that's done by everyone, because they have no right to monitor someone that's not at least suspected for anything. So the question becomes, how do you monitor a subset of the population without looking at all of the population? Those are just some of the things that I'm working on related to this area.